Hello students, welcome back. So today we are going to take up a new topic which is module 3, projection of solids. Projection of solids is a mandatory question in the VTU examination. You don't have any choice for this, and this carries 40 marks. So you should take it quite seriously. Under projection of solids there are 3 drawings in the question bank that was provided to you. The drawing numbers are 11, 12 and 13. D11, D12 and D13. So in drawing number 11 we deal with prisms, which we are going to do today. In drawing number 12 deals with pyramids, and drawing number 13 deal with some special solids like tetrahedron, hexahedron and cone. So today we are going to take up prisms. So this is the model that I have selected to explain you what is a prism. Let me explain the constructional features of a prism. So here you can see this is the base of the prism. The base is a rectangle here. The prism is always named after the base. So since the base is a rectangle here, we call it as a rectangular prism. Similarly, you can have a square prism, triangular prism, pentagonal prism, hexagonal prism and so on. So basically it is named after its base. If the base is a pentagon, we call it a pentagonal prism. If the base is a hexagon, it's a hexagonal prism and so on. Now let me take few seconds about explaining about the constructional features of a prism. So as I have mentioned already, this is the base of the prism. Similar to this, you have here one more face. It is called as the top face. Since it is there at the top, we call it as the top face. This is the base and this is the top face. Both are rectangles. Then this is what is called as the lateral face of the prism. The lateral face consists of 4 rectangles here. This is a rectangle, this is another rectangle, this is the third one and this is the fourth one. So we call it as lateral faces, and all of them are rectangles here. Since it is a rectangular prism, the lateral faces are, this is a bigger rectangle, this is smaller, this is bigger and this is smaller. But if you have a square prism, all the lateral faces will have the same size of rectangles. Okay. Similarly, pentagon and hexagon also, the lateral faces will be rectangles and all of them will be equal in size. Okay. Now you can see the lateral faces are made perpendicular to the base here. This is perpendicular. This is also perpendicular, perpendicular and perpendicular. Okay. Then what is an axis of the prism? Axis is an imaginary line. You can identify the center of the top face, and if you connect it with the center of the base by an imaginary line, that is called as the axis. In fact, it is the center line for the prism. It doesn't exist on the solid, but it's an imaginary line. Okay. Now I am going to talk about the terms that you use with reference to a prism. You have seen in projection of planes an edge or side of a plane. Here this is also an edge. This is another edge. This is the longer edge, this is the shorter edge. Here we call it as edge of the top face. Similarly, this edge if you take, it is called edge of the base. Okay. So the term is edge of the top face or edge of the base. This is the short edge. This is also the short edge of the rectangle. So the term is either edge of the top face or edge of the base. Now the second term, corners. 1, 2, 3, 4. You have 4 corners. They are called as corners of top face. Similarly, you have for the base also 4 corners. 1, 2, 3, 4. They are called corners of base. This is the second term. Now the third term, if you call these points as A, B, C, D and these points as A1, B1, C1, D1, they are all the corners. Now if I consider A, B, C, D, that gives you the top face. Similarly, A1, B1, C1, D1 is the base of the prism. Okay. Now this one, what do you call this one? If it is A1, A1 is called the longer edge. Similarly, B1 is another longer edge, C1, D1. Okay, and then the rectangular face. Suppose if this is A1, B1, B, that's a rectangular face. Similarly, B1, C1, C1, D1, D. This is another rectangular face. Okay, so this is about the construction of a prism, how a prism is made of. Okay, now what I will do is I will once again explain this on the drawing sheet so that you can take a notes of that. Okay, I will move on to the drawing sheet now, where I am representing the terms that are used with reference to a prism. Okay, now I'll come back to the sheet here. You can watch it carefully. So as I mentioned already, we are doing projection of solids, and under that we are doing prisms today. It is covered under drawing number 11. What we are discussing here is the terms used with reference to a prism. Here also I have taken the example of a rectangular prism. You can see this is the top face and this is called the base. I have named the top face as ABCD and the base as A1, B1, C1, D1. Now I am coming to the terms used one by one. ABCD, you find them here, ABCD. They are called corners of top face, as I mentioned already. Now you have got 4 more corners at the bottom, A1, B1, C1, D1. They are called as corners of base. Sometimes you can also call them as base corners shortly. Then the next term is this one, AB, BC, CD and DA. They are called as side or edge of top face. I repeat again, it is the side of top face or edge of top face. Similarly, at the bottom, A1, B1 or B1, C1 or C1, D1 or D1, A1. They are called as sides of base or edges of base. Shortly, you can call them as base side or base edge. Okay. So, the next term, ABC, ABCD, ABCDE. For example, you have ABCD here. That is the top face of a rectangular prism. So, when I say ABC, that should be the top face of a triangular prism. ABCD is the top face of a square prism or a rectangular prism. ABCDE is the top face of a pentagonal prism and so on. Similarly, if I put the suffix 1, A1, B1, C1 is the base of a triangular prism. A1, B1, C1, D1 is the base of a square prism or rectangular prism as you see here. Okay, so that represents the base itself, the base of the prism. Then I have shown you what is longer edge in the demonstration. A1, this is called the longer edge of the prism. Similarly, B1, C1, D1. They are called longer edges of prism. That's what I have written here. It is called a longer edge of prism. Then the rectangular faces, as I mentioned already, the lateral face of the prism consists of number of rectangles. Since it is a rectangular prism here, it will have 4 lateral faces and all the 4 are rectangles. So if you look here, A1, B1, B is a rectangular face. Similarly, B1, C1, C is another rectangular face. The same thing I have written here. A1, B1, B, B1, C1, C, C1, D1, D, etc. They are all called rectangular faces or lateral faces of the prism. And finally, the axis. As I mentioned already, axis is an imaginary line. It doesn't exist on the solid like these edges. So how do you get the axis? Axis you can get by connecting the center of the top face with that of the base. How do you get the center for a rectangle? You can just connect the diagonals. Wherever they intersect, you get the center. Similarly, for the base also, you can just connect the diagonals, you get the center. So, if you connect this O with O1 by a line, by an imaginary line, that becomes the axis of the prism. That's an imaginary line in fact. Okay. So, you can just take down this sheet For your reference, you can just note down in the your sketchbook. Okay. Now I'll move to simple position 1. Just like in projection of planes, here also you have simple positions. But luckily your syllabus is restricted only to 2 simple positions in prisms. So we will talk about simple position 1 first. Once again I'll go to the demonstration and show you what is simple position 1. I'll take the example of rectangular prism once again. Okay, now this is the rectangular prism. You are already familiar with the terms that we are using. So this is your base. Simple position 1 is this. The entire base is on HP with the right side edge perpendicular to VP. So if this is your VP, this is how I will place the prism. This base should be on HP. Okay, and take the right side edge perpendicular to VP. So if it is a rectangular prism and if you want the shorter base edge on HP, I must take the shorter edge to the right side and take it perpendicular to VP like this. Like this, you have to place it. You have to place it on HP. Suppose if you are asked to keep the longer base edge on HP, then this is how I must take the position. I must take the longer base edge on the right side and I must take it perpendicular to VP. Okay, so it depends on which base edge you want on HP. So let us say this is the position. So this is what is called simple position 1. There are 2 conditions to be satisfied. One is the entire base should be on HP. The second is whichever base edge you want on HP when you go to next step, that must be taken perpendicular to VP, preferably on the right side. This is first step. So in this step, you are following these corners as A, B, C and D. The bottom corners you are calling as A1, B1, C1 and D1. Okay. So in this case, I am going to take A1, B1 on HP when you go to second step. And then I rotate the prism like this. This position will be given to you in the problem by giving you the following angles. Sometimes you may be given the angle of the base with HP, or you may be given the angle of this rectangular face with HP, or you may be given the angle of the axis with HP. So this particular position will be specified to you by giving any one of these angles. What are the 3 angles? You may be given the angle of the inclination of the base with HP. This is the base. You may be given inclination of the lateral face, the rectangular face with HP. Or you may be given the inclination of the axis with HP. This will be specified to you in the problem. Any one of the angles will be given to you. So accordingly, you will draw the top and front views. Okay. Then the third step I will be explaining on the sheet. But here one additional thing is, since it is a 3D object, the solid is a 3D object, when you draw the projections, all the lines may not be visible to the observer. For example, the same case if you take, if I am placing it like this, when the observer is watching from the top, this edge will not be visible to the observer. Okay, so when you make your drawings, all the visible edges will be drawn as solid lines or continuous lines, and invisible edges will be shown as dotted lines. Though they are dark, both solid lines and dotted lines are dark, but the visible line is a continuous line, which we call a solid line, whereas invisible line will be dotted line. Dotted lines also have to be made dark. Okay, so this is about simple position 1. Now, when do you adopt simple position 1? When you are given this position, you adopt simple position 1. What is simple position 1? This is simple position 1. The entire base is on HP with the base edge that you want on HP taken on the right side, and it should be taken perpendicular to VP. So in this position, if you draw the top view will be a rectangle. Okay, and what is the front view? The front view is also a rectangle, but this is a bigger rectangle you get. Okay. So I will once again go back to the sheet, okay, and explain you those 4 questions. The first question is what is SP1? The second question is when do you adopt SP1? The third question is how to start, and the fourth question is how to proceed. So after explaining you all these 4 question and answers, we will solve a problem on this case, simple position 1. So I'm once again coming back to the sheet. Yes, here I have written what is simple, all the 4 question and answers. Simple position 1. What is SP1? SP1 is a prism resting with its base on HP with the right side base edge perpendicular to VP. Just now I have mentioned. Preferably we take the base edge on the right side and we take it perpendicular to VP. Then the second question is when you adopt SP1. I have just now shown the position. When the prism is resting with one of its base edges on HP, that is one condition. And the second condition, one of these angles will be given to you in the problem. It could be the inclination of the base with HP, or it could be the inclination of the axis with HP, or it could be the inclination of the rectangular face with HP. So you can make a note of this sheet. I'll pause for just a few seconds here so that you can make a note. You can pause and pause your video and make a note of this. Now I move to this third question. How to start? How do you start the problem? See, as in projection of planes, in SP1 we started by drawing the top view first in projection of planes. Here also you start by drawing the top view first with the right side base edge perpendicular to XY. Then the last question is how do you proceed? This is the chain. You are going to start with SP1. You satisfy HP condition first and then move to VP condition. It is similar to what you had in projection of planes. When it is SP1, you start by drawing the top view first. And when you start by drawing the top view first, you satisfy HPC first and then move to VPC. Okay. So now having understood this, let us solve a problem on a square prism now. So this is problem number 3.1, reference number 1 in your question bank. Please keep the question bank handy with you while solving the problem. Now this is a problem on a square prism. The square prism has 35 mm side of base. So if this is the square prism, this is in fact a rectangle, but here it is a square. So all the 4 edges will be equal for a square. 35 mm are the edges, and the height is given as 60 mm here. This is the height. Okay, this represents the height. Okay. So I'm starting by drawing the top view first. I'm starting with the first step, simple position 1. Since you are solving the problem in first angle projection, this is your XY line represented by VP and HP. There. Now I am going to start by drawing the top view first, which is a square of 35 mm edges. So this is the square. The edges are 35 mm in length. So I am dimensioning it. I will call it as square 35. Now, when this is the prism, we have, when you are looking from the top, there is top face here and there is base here. If you call this point as A and this as B, C and D, just beneath A you have A1, then here you have B1, C1, D1. In total, you have the top face here and you have the base here. So when you are watching from the top, only the top face is visible to you. The base is invisible. So I am going to name the corners like this here. As I mentioned, the top face is visible to you. So A, B, C, D. This is the top face. Beneath this, you have the base, which is represented by A1, B1, C1 and D1. So A1, B1, C1, D1 are shown in brackets. That represents the base. That's it. Now let me show you the axis also in the top view. Let us find the center of the square by connecting the diagonals. These lines will be drawn thin. Wherever they intersect, you get the center, that is represented by O1. Okay. So axis is in fact a line, but the line appears to be a point here in the top view. As you can see here, when you are looking from the top, this is O, and at the bottom you have O1. It's a line, but that line appears to be a point in the top view. Is it not? So that's what I have represented here. O1 is a point. So this is my top view in the first step. We call it as SP1. Now let me complete the front view. So I'll draw the projections. So this is where you have the base of the prism. In SP1, the base should be on HP. Now this is the position of the observer. Okay. You have the point. If you want to draw the base, it is A1, B1, C1, D1. Okay. Now out of the point C1, D1, C1 is visible to observer. So C1 outside, D1 in brackets. We'll put dash because it is front view. Similarly, B is visible, B1 dash, A1 dash in brackets. A is invisible. So this is the base. Now you can take the height. The height is given as 60 mm. So I will take the height as 60 here. The front view of the prism appears to be a rectangle. So this dimension is 60. Now this is the top face. Similar to the points that you have noted here, C dash, D dash in brackets, B dash, A dash in brackets. So this is the top face and this is the base. Though this is a plane surface, it appears to be a line here. This is also another plane. The base is another plane. It appears to be a line. And then you can project the axis and show it in the front view. Oh, this is a projector and the axis is shown by a chain line, and that should be a thin line. This is the axis. So a long line followed by a short line. Long line and short line. You must have seen in your software types of lines. This is called a chain line, which is used for representing the center lines. Since the axis is a center line here, we have used a chain line. This is O dash, this is O1 dash. So this is about the simple position 1. Okay. Now I'll take a short break and then come back and draw the second and third steps again. Okay. I'll come back.